Chapter 12, we have the object-oriented design, okay? And mainly the object-oriented design actually is for the graphic and Windows. We talked about that already, okay? And then for object-oriented design, we have the encapsulation, data abstraction, inheritance, and polymorphism. And so far, you have already learned the encapsulation, data abstraction, inheritance, not yet, polymorphism, not yet, but today we will try to cover a little bit of these, okay? They will try to cover a little bit of these. And then we will get started for there, okay? Now, my first question is like, Ryan, you hear me talk about some object-oriented programming, but so far, how much do you learn about this object since? Still remember what is class and what is not class? Can you tell me what's class and what's not class? Class is what?
The variable?
Yeah, all Python variables are classes, yes, are objects, yes. But what's the difference between object and class? Do you still remember maybe chapter 10? We talk about the rectangle and triangle and circle and rectangle. You remember that chapter? And then it has the area, and it has the string reprint, and then you have a compare function to compare the area. You still remember that portion?
No.
No? Let's go back to chapter 10's project. So in chapter 10, let me show you here, okay? This is the file directory for chapter 10. Okay, probably over here. And this one, we talk about the rectangle.py. Wait, how come this one is empty? Let me see, second. Okay, here we have a rectangle.py in the geometry object. Remember this one? You have circle, you have rectangle. You still remember this one?
Yeah.
And this is a class, right? So what's the purpose for doing class? What's the purpose? So normally we have variable, right?
Yeah.
So normally we have variable like, let me bring up this whiteboard. Normally we can have a variable like A, you can assign with 3, B equals 4, right? And then class, we actually have what? We have that class and then circle, right? And then we do what? Define function, underline init. You still remember this one? And it has cell that say R, right? And you say cell the radius equals R. Remember this one?
Yes.
So this one actually on the left is actually normal variable. On the right, it actually is the classes, right?
Yeah.
So this one actually is a custom class design. Every number is also a class, but class is used to create several circles. Circle 1, circle 2, you can create several circles. And each circle you can calculate its area. Remember that one? So what's the purpose for having a class?
It's to like put things in like a group.
Put things into a class. So you actually can put several variables into a class. And that class is a concept, right?
Yeah.
Say we have circle. We want to create something like a circle 1 equals a circle. Remember that one? Circle
Yeah.
2 equals circle. And here you can put 5. And you can put 3 here. And we can also do the circle, that number of circles. Remember that one? So you can put down the number of circles with a class. Okay? So that's about object-oriented programming so far you have learned. Okay? And the purpose for having the object-oriented programming is mainly for the Windows. Okay, mainly for Windows. So here we have the class. So you can set number of circles to be 0. This one is called what? The class variable. That is belonging to the class. So it counts the number of circles have been created, right? And you have the init. And then init is what? What's the name of this init function? Still remember that?
Yeah.
What kind of function is init is? It's called constructor.
Oh yeah.
So you actually can do what? When you say circle and then put 3 in there and go to see what this one actually is calling this init function, right?
Yeah.
And you put a 3 in there, you will pass the R into the radius, right?
Yeah.
And also you can actually calculate the area by having this radius and the circle, so radius square times pi. So when you do C1 that area, it will give you the area for that circle based on the radius value. Remember that one?
Yeah.
And then here, reprint function, when you do print C1, it actually will print out the C1's data based on the radius and the string over here, right? You use the radius to replace the number here, right?
Yeah.
And then you have the greater to compare two circles, which one's bigger. Same thing for rectangle, right?
Mm-hmm.
Same thing for rectangle. So these two, actually, we call it what? We call it circle, we call it rectangle. But these two actually are actually what? These two are actually called what? Classes, right?
Yeah.
Okay. Now today we are going to cover more about this. So today we go to chapter 10. So let me actually go here, chapter 12. Okay. So today that's in chapter 12. Let's create a class, a file called circle. Okay, let's create a file called circle. Okay, and in this circle, let me actually copy this called circle class over. Okay, so I need to import it mass and then copy this circle here. Okay, and I save. Okay, and then I create some other class called rectangle. Okay, so I have a rectangle class as well. So now I move this class called rectangle over here. Just copy and go to the rectangle. Chapter 12 is a rectangle. Okay, so this one is a rectangle class. So let me actually save it as well. All right, so we have a rectangle class, we have a circle class. So in rectangle, let me also port the import mass over. Okay, so this one actually is rectangle class. Okay, so let me actually save that. Now I'm going to do something here. I would like to create a class called square. Okay, I'll create a class called square. And this square class actually is one kind of rectangle. It's one kind of rectangle. So what I would do is call class, okay, square. And because it's one kind of rectangle, so I will actually do here, I will actually do what? Here I will say, I will actually say this one called Here I'll put rectangle. Okay, and rectangle he cannot see it, so actually I need to from rectangle import star. So I import all the rectangle definition into this file. Okay, so you see it now. So I say that because a square is a rectangle, so I put a rectangle within the parentheses over here. But rectangle is does not inherit somebody else. So this one is the BO, something called inheritance structure. So rectangle is a father of square. Okay, so it's a father of square. Is that okay? Rectangle is a father of square. So what I means father actually means like I have a class called rectangle and I have a class called square. So square inherit all the property from rectangle, right? And then here I have another class called circle, and that's not related to square at all. So here I have a square, and I actually inherit from rectangle, and then here I need to build a constructor. So I build a constructor. Underline, underline, init. Okay, underline, underline. So here I have a self, right? And I'll have something called side. Let's call it S. Let's call it side. I'm sorry. Let's call it side. Okay, and then call it side. But actually, right here I have a rectangle. Right, I have a rectangle, and rectangle actually will do what? Call this an init function, and then have the width and height. Right. So here, because my rectangle is my square is one kind of. My square is actually one kind of what? It actually is one kind of rectangle.
Yeah.
So I would actually do super that underline. I'm sorry. I will call super or underline init. Underline like this, right? And I say side. Okay, and I only do this. Okay. What does this means? This actually means what? Here I have a rectangle and I have a creator, right? So when I actually inherit square inherit rectangle, so this super is a father. So it's a father's init function. I put my side here. So it will pass my side to W and H here. So you will actually create the variable width and height like that. Okay. And then the area is defined, the reprint is defined, greater is defined. So if I don't define in my square, actually I would just follow and using the function over here. Okay, and the data set. So here if I just do this, if I just do my S1 equals square or 2.5, okay, and I print square. Okay, I just directly put in my square. What will happen? It said that it's R, this, right? Because what? Because I inherit a rectangle, so I'll go to here to call rectangle's reprint function, right? I don't have my reprint myself, but because my square is a type of rectangle, right? So it would be okay. And if I put in that SQ is what? Is rectangle. Okay. So if I put in whether my square is one kind of rectangle, it's a false. Okay. But if I say print square is square, let's see, it's also false, right? So here if I say print square type square is rectangle. It's a false, right? And then if I say print type square is square, this one is true, right? So it actually is what? Its type actually is square type, okay? And it is actually not a rectangle type, right? But it actually inherited all of the everything from rectangle. Okay, I don't need to rewrite this different function over here. Okay, I don't need to rewrite this different thing over here. But if I don't like my reprint because it said rectangle R, so if I don't like this one, I can actually copy it and put my square, put into my square function, square class. Okay, so here I just change. Okay, my R I change it to SQ for square. Okay, if I change this one, okay, and I rerun the program, when I print SQ. It says SQ now. So this reprint function actually, the relationship is like this. I have a class called square. I have a rectangle that I inherited a square. I have a square. I inherit a rectangle, right? So here I have a reprint, right? And if I don't have reprint in my square, and I try to print SQ, then I will use this reprint function. Okay, but if now actually I put a reprint in my square function, then I don't actually I no longer need this one. I'm not going to use that function. I'll use my own copy. Is that okay? Is that okay? It's just like you can use your dad's computer, right? If you don't have a computer, you use your dad's computer. But if you have your own one, then you use your own one. Is that okay?
Yeah.
So super means the father class. So I actually create my own constructor, but I only have a site. So I call my constructor super.init, and I put side in there. So the width and height will become this. Okay, width and height become side it will be equal. So here, if I actually print, okay, my SQ.area, I'll get an area for that square. So 2.5 times 2.5 equals 6.25. Okay, but this area function is where? It's not in my square. I don't have an area in my square, right? But actually it's in where? In my rectangle. But here, if I do print, okay, my rectangle, that number of rectangle, okay, let me see if my rectangle has that. It's called number rec. Okay, so there's no of. Okay, if I call this one, right? I print out this one, see how many it has. So here is 1, right? So if I continue to create more, okay, and I put like 3.5, 3.5, 4.5, 5.5, and I say square 2, 3, 4. And again, after that, I print my number of rectangle, and then I run it. Okay, it becomes 4, right? And here, actually, if I say, okay, I add something called R1 equals rectangle 2.5, 3.5. Okay, appear a rectangle. And again, I actually run this one, rectangle done none. Okay, rectangle done none. And I passed. Okay, and this one actually I print this one. Let me see. Okay, this is okay. This is okay. Let me draw. Okay, so after that I create a rectangle. See how many rectangle now. So it become 5, right? So it become 5. So there are 4 square, 1 rectangle, totally 5 rectangle. Okay, and 1 square. But here actually I can do this. Over here, I can actually do what? CLS, right? No, here. I can right here. I can actually in my init counter here. I'll say CLS. No, I put it here. No, I put here CLS that number of square equals 0. Okay, and whenever I create CLS that number of square equals 0, increase. Okay, let me check. Okay, maybe not CLS. Let me check. Let's say Python class CLS class method function current class. Okay, let me see. Yeah, it's a CLS. Yes, lowercase CLS. Okay, so you say that's current class number square. So here, let me do this one called print. This one called square. That number square. CLS not defined. Let me see. CSS. Actually do something. Oh, you need to pass CLS in. I'm sorry. So here I actually need to pass CLS in. Okay. So I need to pass my CLS in. Let me see. Okay. Let me see. No, oh, this one's not okay. So this one put it here. Okay. Let me run this one and try. Oh no, this is not okay. So I have to do something else. Okay, I have to here define call increase and not cell called CLS. Okay, and here says CLS dot num square plus equals 1. Okay, and this one not run this one, but run this one, but run increase. Okay, I run self that increase. Okay, so here let's try. Okay, let's try. This one is square root is on CLS square root. Let's see how this one will move. Okay, I'll check this one. Okay, I'll check this one later. Let me remove it. Okay, the CLS means current class, but this one doesn't work out. So I'll check it later, okay? Don't worry. So this one actually, just take it out. So here we have a counter for inheritance of a rectangle, right? And then you inherit create two functions. So this one, actually it is a reprint. So it actually will override the definition in rectangle. So you have your own definition. If you don't have this reprint definition, you will use your parent class definition for reprint. And here, if you have the definition, then your father's definition won't be used over here. Okay, so that's the kind of class relationship we call the inheritance. We call this one called inheritance. Okay, so you have like normally what is inheritance? So something like we have a person, right? We can have a class called person. So person is a person, and then you may have something called staff, right? So staff inherit a person, and here you may have student. Student inherit a person, right? And staff you may have teacher, and then you may have like accountant, right? The school may have some accountant, and may have principal, right? So these are different staffs. And student, you may have high school student, and you may have elementary school student. Okay, these are all different kind of student. But student, elementary school student, high school student are both student. A student is one kind of person, and principal, teacher, and accountant all are staff, and staff is a kind of person. Okay, and these build up the so-called inheritance tree for the different classes. Okay, so chapter 10 we talk about a single class, and here we talk about the class-to-class relationship. Is that okay?
Yeah. Yeah.
So circle is one kind of geometric object, and then rectangle is one kind of geometric object, and then your square is one kind of rectangle. So that's the relationship over there. So here actually we have rectangle, square, and then we have circle. With rectangle we have square. So now let's create something called what? Is something actually called geometric object. Okay. So here we create something called geometric object. So I import mass. Okay. And this geometric object, I just call it what? Class geometric object. Okay. And here I actually do nothing, and I just do pass. Okay, I do nothing, and I just do pass. Okay, I do pass. And then here in my rectangle, right here, I just put geometric object. So my rectangle is one kind of geometric object. Let me see, geometric object. So here my rectangle, I need to import geometric object. Okay, so my rectangle become one kind of geometric object. And my circle too. So here I will also include geometric object. Okay. And then here I have something called what? Something called geometric object. Okay. Okay, so here I have geometric object. So both my circle, rectangle are geometric object. So here, let me go to my geometric object. Okay, I do nothing, right? I do nothing. That's fine. So here I will say I have my rectangle 1 equals rectangle 1 1. Okay. Here I should also include my rectangle. No, I should do this. I should do. Oh no, let me not doing this one. Okay, I'm sorry. Let me not doing this one. Okay, let me not doing this one. Okay. Let's see. Let me actually create some new program called TestGeo. Okay, in TestGeo from geometric object. Okay, and then I import everything right from my rectangle. Import everything. Okay, from my circle. Import everything. Okay, from my square. Import everything. Okay, I import everything from different files. So here in my rectangle, I change it. Okay, I don't want to do this one. I change it from my geometric object, import star. Okay, and here in my circle, I do the same thing. Okay. So from my geometric object, import star everything. Okay. So now I go back to my test geo objects. So here I say R1 equals rectangle 1 1. Okay. And then R2 equals rectangle 2 2. Okay. And I say C1 equals circle 3.0. Okay. And I say C2 equals circle 2.5. Okay. And here I have my square 1 equals square 3.4. Okay. With this, actually here I say like G list. Okay, create a list. And then I put my R1, R2, C1, C2, and SQ1 in there. Okay. And after that, I say for OBJ in G list. Okay. And I say print OBJ. Okay. So I create a list of different circle, rectangle, and square. And each time I get an object and I print that object out. Okay. And let's try. See here. I actually print now the whole thing over here. Okay, the rectangle circle, I'll print it out. And here, because I want to actually make sure the rectangle doesn't got executed, a circle doesn't got executed, my square doesn't got executed. So here I need to put everything here to my main function. Okay, because it got executed. So let me actually remove these different things. Cut it and put into my main function. Okay, and over here I say if under the name equals under the name then do main. Okay, and I copy this whole line to some other classes. Okay, some other classes like this one. For this one here, but I don't have main, so I just do my main and here say class. Okay, do nothing. But it actually will prevent the class to run something I don't need. And pass here. And here something I do define main and pass. Okay. Okay, you see now the whatever run in square are gone. Okay, so the test geo will just get this different scene over here. And actually, I can also do this. I can also print all the object that area. Okay, so you print the object, and then here I will say my obj, comma, right? And between comma, I actually separate by a equal signs. Okay, and this is a print object. I'll delete. So I print this one. It becomes my rectangle area is 1. My rectangle 2, the area is 4. My circle 3.0, my area is 28.27. My circle 2.5, my area is 19.60, about 63. And then square root, a square of 3.4, my area is 11.56. Okay? So that actually each object is one object in my G list. And every time I can get a object, and then I print out the object's name, and also print out the object's area. Is that okay?
Yeah.
So what's the purpose for this one called geo object? What's the purpose for this geo object? It actually do nothing, just pass. But what's the purpose for having this one? So now you have some sort of geo object, right?
Mm-hmm.
And this geo object, under there is a square. Square inherited this one. And you have a circle. Circle also inherited that one. Mm-hmm. And then under your rectangle, you have a square. So what's the purpose of having this one? But it do nothing. It just pass. It do nothing. It just pass. And then what's the purpose of having this one?
To like show that it's there, but then you pass it. But you don't really need it.
No. Showing it make no sense. Showing it actually make no sense. What is put over here? What is put over here?
Shape. Oh.
No. It has a rectangle, a circle, and square. What? These are different classes, right?
Mm-hmm.
But how comes they can put into the same here, the same thing here, and I print out all of them?
Because they're all geometric objects.
So actually, so what's the purpose of geometric object? It actually group everybody together.
Yeah.
Right?
Yeah.
It actually group everybody together. Is that okay?
Yeah.
You get to group everybody together. Okay, so that's the concept of having this one. But this one actually can be designed in more detail. So here I actually just show you the purpose of having that, and then you build up the relationship for the inheritance structure. So inheritance is to group some different classes together so that conceptually you know that they are actually the same type or similar type. Okay? Or similar type. So here we finish this inheritance. And now we have model view controller approach. So when you actually look at JavaScript or some website, later we will talk about this next semester. What you would do is like you have a browser, right? And there's the server, say Amazon or somewhere, right? And you are sitting here. You put something here, and then it actually what? There is something called view. You see the windows on browser, and you click something, so that something that you have sent a request to my server. That model is in server. So here I actually get the name, get some database, get some data, and then I send back to my controller and showing on my view. So your name or your data on here, say your school loop or something, or your GP or something, you just type in some data and then you will send back to here, and this guy will show it. So this is called the view is something you will see. And then here you have a model. Model is the data you search from the online, your school website or Amazon or some cloud site. Okay, so that's called model view controller approach. So here has some more detailed model view controllers approach. It's actually related to the graphic design. And in Python, there's a PyQt. Qt we pronounce a Qt. And they are also like what? TK Inter, okay? And we use the graphics, right? Graphics also TK Inter. There are a few different packages that help you to do graphic layout and also networking or game design, okay? So that's the client and server relationship, okay? So here we actually will teach you the different objects, okay, and teach you about the interfaces and teach you how to code it, okay? So we have the Rocky Ball simulator, okay? So there's a controller called main function, there's a view, there's a control function, controller, and there is a model, okay? And that's different functions. So that one actually a little bit too difficult, so we pass it. Okay, here we have the player. So Rocky Ball actually, because it involves some more stuff. Okay, so this chapter 12 actually not much to talk about, okay? But right here, we actually introduce this geo, object, and circle and square, okay? And let's do something else over here, okay? We still have time, let's do something else. Let's do what? Let's new a Python file. Let's do simple TicTacToe. Okay, let's do TicTacToe. Okay, let's do TicTacToe. So here I would have what? I would have a TicTacToe. So from graphics, import everything, right? So here I would actually do a TicTacToe game. So I will have my main function, right? And here I put pass first. And then here I'll say if my name equals under the name, okay, wrong name, okay. So here I have my main function, and here let me actually call something call class TicTacToe game, okay. So this TicTacToe game I may have defined underline elite underline, okay. I should have W and H, okay, and here self that what? Self that my width equals W, okay. Self that height equal H, okay. And then these are the W and H for the TicTacToe game, right? So right here, let me say self that win equals graphics graph win of TicTacToe, and I have my width and height. Okay, so I pass myself that width and height over there, right? And this TicTacToe game, I should also have my self that background equals BG. Okay, so here I put a BG in here. Okay, and then here I say self the foreground set called foreground equal FG. Okay, so I also pass my foreground over to my foreground. Okay, so here my window, I will say window.set background, and I put my self.background. Okay. Okay, that's good. Okay, and then this is good. Okay, this is good. So here, what I'll do is like here I actually should do what? Define get window. Okay, and then here I will return self.win. Okay, get to here. So here in my main function, actually I'll do what? TicTacToe, and I put in 800, 600, and then here I say black, and foreground, let me use yellow. Okay, these are 4 numbers, and then the 4 number. Okay, let's do it. Okay, let's actually do it now. For now, okay. So I might run my TicTacToe game. Wait, it actually where it show up? Oh, it doesn't show up. It doesn't show up. Okay. So here, let me see. Here, it doesn't show up for too long. So let me see. Okay, here's my TicTacToe. Here is my. Where's my TicTacToe? This object. No, not this one. Let me close this one. Okay. No, that's it. Where's my TicTacToe? 12 demo. Okay, right here. Okay, my TicTacToe. So here, actually, after I set up the data, here let me actually have this one called define run. Okay. Okay, here I will say like while or true. Okay, and while true, I will actually what? Have this one. I should have self.win.redraw. Okay, self.win.redraw. Okay, and that's it. Okay, and at the end, actually, I'll say self.win.close. Let me see. Okay, and here after that, my TicTacToe I assign to T1. Okay, and here I say T1.run. Okay, so I create a TicTacToe and T1.run, and I actually run this one. Okay, create a window and it run. Okay, so this one way is the way that actually I write it in object-oriented way. You know, in the past I don't do. Last time we do the traffic light, right? Let's compare the traffic light and this one. So last time I do the traffic light, and I'm writing the traffic light in non-object-oriented way. Last time I do it in non-object-oriented way. Let me actually bring that up. Okay. So last time here I have. Let me see. I bring out this drawing. And I'm in chapter 11 last time. So that time I had this one called dictionary 1. That one is this traffic light. So let me run this one, dictionary 1. Okay. And that has this one running, right? But this one actually what? Everything is in function, and I have a main function, but it actually put everything in main function and not put into class, right? So actually it's very unorganized, right? It's very unorganized. But this time actually I put my TicTacToe game into into a class, and that class is called what? That class is called TicTacToe game. Okay, that class is called TicTacToe game. Let me see. Where's my TicTacToe game? That class is called TicTacToe game. So here, actually, I have a wrong function. I have init function. So my init function, I will create some parameters and create a window and then set the background to black, right? And when I start to run, actually, it will run my TicTacToe game, and then actually you will redraw it. Okay, every time you will redraw it. And then if I get window, I get that window. So here I create a TicTacToe game, and I call it T1. And my T1 is actually a TicTacToe game object, and I say run. But this one actually I can actually minimize it, so I don't need to actually create an object. I just do that one and then run over here. Okay, and I don't need that T1. T1 is okay. You actually assign to some object, but actually I don't. Every time I don't need that. So here, let me run again for this. Where? No, I'm running the wrong one. I'm sorry, I close this one. Let me run this one. My TicTacToe game. How come it's not in TicTacToe game? So let me save them. Okay, here. Okay. So I run this one. And then if I click here, I will close it. Okay. Now, that's actually my simple TicTacToe game. But this one is not enough. Okay. I did not do anything. So here, actually, the first thing I will do is that from actually import time. Okay, I import my time, and in my game loop, this one I call it game loop, right? So in the game loop, what should I do? Ryan, you still remember what need to put inside the game loop?
A game loop?
Yeah. You still remember? So you actually have three things: data update, right? Redraw the window, and then hold for a certain time, right?
Yeah.
Remember that one? We have a fresh light. Update the state, and then print out the green light, and then hold for 2 seconds. Remember that? And then next time I go back the loop, update the color to yellow, and then redraw it, and then hold for 2 seconds. Remember that one?
Yeah.
Okay, so same thing here. I need this. Here I will need to have this one, and then I say my time loop sleep. Let me sleep for 0.1 second. Okay, so every 0.1 second, I redraw it and then I print. Okay, I actually print. Now actually this one is actually what? This one is actually so before my redraw, I need to update my data, right? I need to update my data. So here, let me do something. Here, let me do something. Every time I actually my init function here, I set background, right? So what I would do is right here, my width and height, I know that. So here I should create something called line equals line. Okay, and I should actually do what? I have a background and I have a foreground, right? So I cut into a TicTacToe game is 1/3, 1/3, 1/3, right? So here I should have my background width divided by 1/3. So here, let me see. My line would have my 0.1, right, point, and my 0.2, 2 points. And these 2 points, where should I put there? Where should I put these 2 lines? Because I want to have a TicTacToe game, right? So my TicTacToe game actually look like this, right? And you can put this, and circle there, right? So I need to draw some line, okay? I need to draw some lines. So those lines should be here. This point is what? This point is 1/3 width, right? And height is 0, right? this point is 1/3 width and height is h. Okay, so I need to connect these 2 points together as a line. And let me draw it as what? Yellow color. Okay, let me draw it as a yellow color. So now, because yellow is more visible. So right here, actually, let me use this one called my cell dot width divided by 3. Okay, my height is 0. Okay, here I have my cell dot width divided by 3, and then my height equals cell dot height. Okay, and then I want to draw this line, and I say my line. Okay, now let me call it this one, call it line 1 because I have 4 lines to draw. Let me call this one line 1. So my line 1 dot set width. Okay, this one let me set width for about 7. Okay, how about 8, and then more visible. Okay. And then here, my line 1 dot set color. So the color I would like to use is foreground. So I do self dot foreground. Okay. Line 1 I would like to set color. And then I will say my line 1 dot draw. And I say self dot win. Okay, let me actually bring up the graphic class description. Let me open the file. It actually under here, I bring up the Python course, Python programming essential. Here I actually have this one called where? Let me see. Here should be DOC, and here I have a graphic class. So here I want to draw some line. Okay, let me look for a line. So here I can do Control F and type in line. Okay. So my line actually over here I choose next one. Oh, it should be set outline. I mean, let me see. So I have a line. So in the set outline color. So let me set outline, not set color. Okay, it's called so-called set outline. So here let me call it set outline. So set outline, let me see. Is that set outline? Actually set outline. Okay, so that one I finished that. This one I have typo. So okay, so here I have my line 1 and I try to draw it. Okay. So here actually let's do this. Okay, let's do this. Run this one first. Okay, I draw a line, right? A yellow line. Okay, I draw a yellow line. That's fine. Okay. Now I need 4 lines because I need 2 vertical bar and 2. I should have 2 vertical bar and 2 what? I need to have 2 vertical bar and 2 horizontal bar. So let me copy, paste, okay? And then the first one I call it line 1. Here I call it line 2, line 2, line 2, line 2. And then line 3, line 3, line 3, line 3, and then line 4, line 4, line 4, line 4. Okay, 4 lines. So let's look at the line 2. Line 1 actually is 1/3. And this line 2 is to be 2/3. Okay, 2/3. So this line 2 is 2/3. Same color, same width. Okay. And then here the line 3. Line 3 I actually should use my width to be 0. And then I change myself that height divided by 3. Okay. Same thing here, I should use my self that width totally and self that height divided by 3. Okay. And this whole thing, let me copy over and paste on my line 4. Okay, so here my height, I put it 2. Here my height I times by 2. Okay, no, that's wrong. See whether I have all my bar ready. Okay, this one's good, right? Look more like TicTacToe game now. Is that okay? It's a TicTacToe game, right? This one more like a TicTacToe game. Okay. And this is TicTacToe game. And let's see. Now I actually need to wait. Okay, I need to wait to see if someone click, right? If someone click. So actually right here, here I would wait. So this one actually, let me see, check mouse click. Let me see, let me look at the, let me see here. Here, let me see, mouse click. So no, there's no mouse click. Let me check if there's a function called mouse click. So get mouse, there's something called get mouse, and check mouse, similar to get mouse, it doesn't pause where user click return the last point. Okay. So window.check mouse, you return a point. So there's a get mouse. Okay. Get mouse. Okay. The point. When the mouse was clicked or none, even since the previous call. Since the none, if the window has not been clicked since the previous call to check mouse or get mouse. Okay, there's a previous use for, okay. So you return none, okay. So here, let me see. Okay, so here, let me see. Let me go back to my function over here, okay. So here I say that I should have a p point equals get mouse. Okay. So here I say if p equal none. If not equal none. So here I have a Windows. Select that window, get mouse. Okay. And if I don't have if I click the mouse, then I actually will redraw the window. Okay. If I don't click the mouse, then actually it won't redraw the window. So here, let's do this. Okay. So here, let's do this. Let's actually draw this TicTacToe game again. So now you don't see any blinking. Okay, because it will only actually when it click. So you will redraw, click, you will redraw, click, you will redraw. Otherwise, if you don't click, it won't redraw. Every clock cycle, it won't redraw, right? So now actually I need to do here. I actually set up here, okay? So here what I should do is, here I have these different things. So here this we have too many nitro, okay? So here let me create a new function right here. Let's do a new function called define called drawable. Okay, I drawable. I actually define drawable, and then I cut this different line to a drawable. Okay, cut different line to a drawable. You'll redraw the ball. Okay, and then here I just do. Here I just do what? Do self that drawable. Okay. And then I don't need to, my initial condition, I don't need to see the ball being drawn. Okay? So here, let me run my TicTacToe again. Okay? and I click, it will resort. But right now you don't see it. Okay, right now you don't see it. Okay, next one, I need to set the font size and let me do this one. Okay, so here I need to have my self.o. Okay, I will be equals what? I set myself.o to be this. Okay, because I want to create a TicTacToe game. So actually my bold will be this. Okay, here I start with empty space, empty space, empty space. Okay, start with empty spaces. Okay, start with empty spaces. Okay. Okay, start with empty space. So I create a ball. Actually, that one actually is totally empty space. Now I need to have my font size. Font size. So my font size right now set to right here. That's to 200. Okay, my font size set to 200 may be too big. I have 800. Okay, 200 is okay. Let me actually check my text. Okay. So I need to check my text. Let me see. I need to check my text. So here I say check my text box. Okay, I need to check my text box. So my text box is, I have text box. Let me see my text box. So my text measure, actually I use some point, and then this is a center point, right? This is center point. So the center point, so totally is 16. Okay, 135. Okay, that's okay. So let's do this. Okay. So here let me do cell. Okay, and then here that cx. Okay, equals cx. Let me do have like cell the width. Let me actually set actually use what? Use width. Let me actually do, no, let's try using W. Okay, so W times divided by 6. Okay, that's my center X. Okay, and this one is W divided by times 3 divided by 6. Okay, and W times 5 divided by 6. Okay, that's my first row. Okay, and I continue to have my W divided by 6, W times 3 divided by 6. Okay, and W times 5 divided by 6. Okay, that's my second row. And then actually I do my third row the same thing. Okay, that's my CX. Okay, that's my CX. So that's my center point for each row and row. Okay. Then actually after that I will generate my center Y for each box. Okay. And after that I will draw different label on it. Okay. Okay, so here let me actually do this. Let me actually copy, okay, and then paste, and I change it to center Y. So my center Y will be W. Here, this one W. So this one actually I delete this 3 and 5 here, and this one I change to times 3. Times 3. Okay, and then here I actually do this one called times 5. Okay, and 5, okay, and time 5, okay. So I have a CXCY ready over here, okay, and font size to be 200, okay. Here, let me do it. It also self the font size. Let me change it to self.f, okay. Now here I get my mouse, and here I say it actually is what? It actually is a P. And then this one I got a point, right? So my point I should return my something called row and column, okay? And then here I should have a function called self.getBox, okay? And I enter my P over there, okay? And now I need to define a function called getBox. Okay, so define a function called getBox. This one actually I'll determine which box I get, right? So I put a point here, right? So I have x equals p dot get x, okay? Y equals what? P dot get y. Okay, and here actually I can directly divide it by width times divided by 3. Okay, and here I should actually what? Do this. Okay, here I said divided by my height, and here divided by 3. Okay, here I say self. Okay, and here I get my x and y. Okay, so I just return my x and y. Okay, and then right here, let's see what's what do I get? Okay, my row and column. So here, let me say print row equals comma row. Okay, and then column equals column. Okay, so each time when I click, I will print out which box it actually clicked. Okay, so let's see. My TicTacToe game, I run it, right? Wait, unhashable list. Where is unhashable list? Main function TicTacToe run unhashable type list. So here I have this one. Let's don't do this. Okay, let's don't do this. Let's don't do this. Okay, just get the program run first. Okay, so right here I have this one. So I click this one. I have my row 0, 0, column 0. This one row 1, column 0. So this is wrong. This should be row 0. Okay, this one become row 2, column 1. So the row and column are different. So row and column are different. So let me go to here. So my x should be my get y. Okay, should my get y, and then x should be my get. No, let me change this. Okay, this one still be get x. Okay, this one still be my get y. Okay, so here let me actually do this one. This one is called my j column, my I. Okay, okay, and I return my I and j over. Okay, so that one actually will I'll get my row and column. Okay. Okay, so here I actually will click, and I will get my right column and row. Okay, So before that, actually, I should do this one. I should actually return integer type. I don't want to have floating point type. So I convert them into my integer type. So when it print out, it will be actually the integer number. Okay, so it give you 0, 1, 1, 0, okay, something like that, okay? So that I get the integer type. Now I need to throw something there, right? So here, before we get started, so here let me say my turn, self.turn equals x, okay? So self.turn equals x. So I get my x and y. So next, what should I do? Actually, I should get my row and column. I should put a text equals text box, and I should have a point, and then put my self.turn over there. Okay, self.turn is actually a symbol. Okay, it's actually a symbol. It's a symbol. So where should I put it? I have my row and column, right? So I have my row and column. So here I should have my self.column and self.row. This one times width. Actually, row should be height. Okay, I'm sorry. Height divided by 3. Okay. Self.height divided by 3. Okay. And here actually this one should be self.column times self.width divided by 3. Okay. Self.height divided by 3. Okay. And then what? I actually should do t dot set size, and then here's self.f. Okay, set aside to be the font. Okay, and I actually t dot draw, and then here's self.win. Okay, after that I will say if self.turn equals x. Okay, then my self. So I should do this one. I should just do self.turn equals O if self.turn equals x. Okay, else give a x. Okay, and let's see. Okay, let's see. So here I have TicTacToe again. Click. Oh, I'm sorry. What's going on? No attribute for COL. Let me see. No attribute for COL. Oh, this one is not COL. It's actually only COL. There's no self. Okay, I delete this self away. Okay, now let's do this one. Okay, I click this one. Wait. Graphic, illegal option. Let me see. Set size. Is that set font size? Okay, let me check my menu. Okay, my text box. My text box actually it has a set size. Oh, need to be number of points. So set size here. Let me see. Set size F. My self.f is 200. So 200 is not an option. So let me try some number. Okay, 200 is not an option. So let me try 64 first. Okay, see if 64 work. Okay. script. Oh, that option. There is no such things as set the size. Let me actually just put a number in there. Let me see if my set size, set 24. Say I don't know what size is supported. Is it right here? No. So let me see. It's not on the right location. Okay. Oh, so I see. I make a mistake. So this one actually, let me see. This one should be this one divided by 6. So it actually should be like divided by 6. So here the number should be 0. So here, let me see, it actually should be this one times 2 plus 1, okay, times this one. So this one height should be the same thing, 2. And right here, I should have this one should be row plus 1, okay. And here it should be this one row also times 2. And then T also set color. Oh, there is no set color. Let me check my menu again, okay. So it's not like, let me see. So for the font, I should have set face, Arial, set size, set text color. Okay, set text color to yellow. So it's called set text color to yellow. Okay, so size, let me try 96. Maybe 96, there's a 96. Okay, let me try. Oh, there's no 96. So what are the size supported over here? It only set, it actually only support, what? It only support 5 to 36 points legal. So let me actually just use a 36 now. So maximum is 36, but this actually won't work. We have to try something else, okay? We have to try something else. 36 is not good enough because it's too small, okay? But at least this is working. Is that okay? You still can run the TicTacToe game on this one. Is that okay?
Yeah.
So next time we will come back to actually finish this one and start to look into how to make it bigger font and also maybe one side to become computer to play. Is that okay? Is that okay? Today we finished up to the join ball, right? Yeah. But it's still human to human playing, right? So next time we will continue this part and then see if we can make the font bigger, right? It actually only support up to 36 based on the graphic one we have here, okay? So we definitely need to draw a bigger font. It only support to 36. But 36 is visible, but not actually that great. Or we should make our board smaller. So here I'm trying 800. I'm trying something called 800, 600. If we change it to, say, like 400, 200, say, 300, maybe that is a better option. Let me try. Okay, it's 400, 300. This one probably better. Oh, this one's good, right? So we finish this single player mode. And then you need to self print, put it down there, right? So next time we need to consider how to make it a game that can have the computer to play with a person. Okay. So that's it for today. Any question today?
No.
Then I'll send this program to you. Okay.
Okay, thank you.
Okay. Bye now.
Bye.